Hello guys, so today we're going to be talking and discussing the concept of implicit differentiation and its many uses, which can all be found in Chapter 2, Section 5, so 2.5 of your calculus textbook. To begin, let me explain what exactly an equation in implicit form is as opposed to explicit form, which basically explicit is what we've been learning to differentiate. So like y equals 2x squared, where y is explicitly, so you see that explicitly, which is marked by the equal sign. It's explicitly defined as the function of x. So because the y can be interchangeable for f of x equals 2x squared. So it's the function of x. So implicit form is just when the equation is when the equation's function is implied like the equation x squared plus y squared equals 9. So implicit differentiation is used to find the derivative of these such equations by taking the derivative with respect to x of all aspects of the equation. So we're going to do this one first. So let's write this a little bit smaller. So we're going to take the derivative with respect to x of x squared plus the derivative with respect to x of y squared equals the derivative with respect to x of 9. So we already know by the power rule, the derivative with respect to x of x squared is just 2x, because we have that n times x to the n minus 1. And we're going to skip this for a second. And using the constant rule, using the constant rule over here, what we learned, the derivative of a constant is 0, so the derivative of 9 is 0. And so what we're going to learn is the new concept that we just recently learned, which is the chain rule. We're going to use to do this because first you're going to use the power rule to make this 2y and y to the n minus 1. So 2 minus 1 is just 2y. And then the chain rule, you have to also take the derivative of the subject, so that's where we get our y prime. And this is what it's going to look like. So we're going to erase these right here. So next, and this is the same for all equations, next we're going to next we're going to want to isolate, or sorry, to complete the differentiation, we must find y prime so that it is the derivative. So continuing, we need to isolate y prime. So 2y y prime equals negative 2x. And then we're going to divide out by 2y, and y prime equals, the 2's are going to cancel out. It's going to equal, I'll rewrite it over here because we don't have that room. Y prime is going to equal negative x over y. So we got the 2's cancel out and the negative stays. So let's go on. That's all that's needed to do implicit differentiation, actually. But this differentiation form can be used in many of the same ways as the explicit differentiation we have already learned about, which is to find the graphs or the slopes of different implicit derivative functions, or finding their second derivative implicitly, or even finding the tangent line of a graph implicitly. And so the only difference essentially between the strategies used to find these, or where you can apply explicit or implicit, is that the implicit function is only used when the function can't be explicitly solved, or finding the their derivative is too difficult. So most of the time you're just going to be using explicit, but this is why we're going to be learning, or this is why we specially learn implicit for these special situations. So let's move on. So we have the equation, let's do some hard ones. We have the equation 4 cosine x sine y equals 1. So we're not going to do you don't do anything to it. The very first thing you do is take the derivative with respect to x of both sides. So by the constant multiple rule, we're just going to put 4 out over here because it won't be derived anyways. So 4 times the derivative with respect to x of cosine x sine y, and the derivative with respect to x of 1. So we know that by the constant rule that equals 0, and then using the product rule on this one, we're going to have to expand this out. So using the product rule on this side, we have 4 times the derivative with respect to x of cosine x is going to be negative sine x times, and using by the product rule, you don't take this out, or you take the derivative of one of them at a time. And continuing, we have the derivative of sine y, which is going to be or the derivative with respect to x especially, which is going to be cosine y times y prime. Because remember, we want to be able to have that y prime to solve for. And then just the cosine of x. So multiplying all of this out, we're going to have negative 4 sine x sine y plus y prime cosine y cosine x equals 0. So let's add this. Sorry, oops, forgot the 4. Let's add this. So 4 sine x sine y. And then, so let's continue. So for y prime cosine x cosine y equals 4 sine x sine y. So we're going to try to isolate y prime. So 4 cosine x cosine y equals, or sorry, my bad, divide that out. So y prime equals 4 sine x, sorry, the 4's cancel out, sine y over cosine x cosine y. And this is essentially the answer, but if you wanted to simplify it further, you could say y prime equals tangent x tangent y. But either way, they're going, if you needed to plug in any values to it, like what we said, if you needed to apply it using the implicit differentiation, then either of these would work. So let's try one last equation using implicit differentiation. So let's try x squared y plus y squared x equals negative 2. So remember, take the derivative of both sides first. We're just going to write that up here. Take the derivative of both sides first. These are two separate things. They're separated by the addition sign. So by constant rule, this is 0. And then this side, we have to use the product rule twice over because they're separated by the addition. So the derivative with respect to x of x squared y is going to be 2x times y. So now we're going to take the derivative of y, which is going to be just y prime. So 2xy plus y prime times x squared plus, so that was one product rule being used, and then plus, so now we're going to do this one. So derivative of y squared is 2y, y prime, that was using the chain rule, times x plus, the derivative of x is just 1, y squared equals 0. That's getting tight. So simplifying this, we have 2xy plus x squared y prime plus 2y y prime x plus y squared equals 0. So now we want to isolate our y primes right here. So we're going to subtract 2xy and y squared. So this comes out to x squared y prime plus 2y y prime x equals negative 2xy minus y squared. If you've got that, we're going to have to erase. So we've got x squared y prime. We're just going to rewrite what I just wrote. Y prime x equals negative 2xy minus y squared. So y prime, we're going to isolate y prime by factoring it out. So y prime times x squared plus 2y, 2xy equals negative 2xy minus y squared. So we're going to divide that out. That will be clear. Negative 2xy minus y squared over x squared plus 2xy. And then, so making that a little more simpler, y prime equals negative 2xy minus y squared over x squared plus 2xy. Rewrite that. And that's your answer. That one was a little bit complicated. And if you work well with that, I think you should be just fine. Hasta luego. Bienvenue. Zhejian. До свидания. Goodbye, guys. See you next time.